Oops, I don't know why I saved it. Okay, so we're going to be working with some fractions today. Okay, when we have a fraction, it is sometimes possible that the denominator could be a nice candidate for substitution. Okay, somebody please tell me why in this example right here, the denominator is a nice candidate for a U substitution. Nathan.
Because you could put -1 and
Okay. Okay. What's something else?
So going off what he said with everything being inside, it sort of acts like the inner function. Once you put it in that form, it acts like the inner function.
and it's not
Okay.
like ideas or something.
Okay.
It's like a simple.
Okay. What did you say?
So it has an X in it.
Okay. Now I know that Brady was joking when he said that, but I did want somebody to point out that X in the numerator.
Yeah, see. I'm kidding.
Okay. Without that X, could we do substitution?
Oh, you could, but there's no point. But there's no point.
Okay. Well, without that X, then it would be the arctangent rule.
Oh,
So we're not going to do
Let's
it.
not do that.
Okay. If we let U be x squared plus 1, what is du? 2x dx. And we have x dx, right? Okay, and I have x dx. So what do we need to do? Okay, this 1/2 is going to have to go in with the du. So our integral becomes 1/2 1 over u du. Now I know Nathan mentioned changing it to the negative first power. I'm not going to do that. Why?
Because that's natural.
Wait, how'd you get 1
Because I let u be the denominator,
Okay.
and then we replace dx dx with 1/2 du. Okay. So anytime we are taking the antiderivative and our power is -1, it's going to be easier to keep it as a fraction so we can recognize that it's the natural log rule. Okay. So this integrates to 1/2 the natural log of the absolute value of u plus c. We cannot forget to plug u back in. Now, something I'd like to talk about with this answer, x squared plus 1. Okay, what do the absolute value bars do? Oh, it's always positive. What's true about x squared plus 1? It will never be negative, okay? So, and it's always positive. So it is okay to write your answer without the absolute value bars in this case, because what is inside will always be positive anyway.
Like,
If you,
like, I understand how the x squared can be, but why do you need the absolute value?
because the natural log has a domain of positive numbers. We can't plug negative values into a natural log. That's why we have the absolute value bars when we take the antiderivative. Okay. Is that good?
Yeah.
Okay. Now, let's go back up to why I wanted Brady to mention that x. Okay. What's true about the denominator compared to the numerator that gave us a nice u substitution? It's a degree less. When we do that substitution, when we do our derivative, that power goes to 1 less. Okay. So when we have that relationship, you have a look on your face like you're not buying it.
Not buying it.
What are we fine?
Okay, what are you confused about?
It doesn't.
Why does it have to be one list?
Okay, well, if we let the denominator be our u, we have to take the derivative of that. And if we're using the power rule, then the derivative has a power one less.
Are we going to deal with?
Yeah.
Okay, and so that would need to be in our numerator somewhere. Okay, so if you have polynomials, if your numerator is one less degree, it's going to be a nice, hopefully nice for 7%. Okay.
Wait,
Are
so,
we going to deal with that one that doesn't have?
One case, but I'll tell you how to do it. Yes.
So would it be wrong if you did it like with the -1 and everything and just that one?
Well, no, because it's still going to be the natural law. Right.
Yeah, I guess.
Would,
I just, so like, what are you saying, like every fraction is gonna be a natural logarithm?
No.
Oh,
But a lot of the ones we're going to work with today. Okay. Okay. Who has an idea?
what did you say, Tanya?
Secant squared is.
Okay. I hear two tangents. Jimmy, you said it first. Why would you being tangent be nice?
Wait, are we allowed to, like, rewrite them like cosine over sine, just to like, see if we can eliminate anything? Cause
Mhm.
isn't secant 1 over cosine squared?
Mm-hmm.
That would do.
Well, how are you gonna?
Is that what you'd like to do?
no.
Let's do it.
Well, how are you gonna get rid of something then, because they're not?
Use the bottom sign for cosine, so you can like just copy down, flip it.
I gave you.
That's already my own lady.
I actually didn't. It's cool.
We'll try that again.
It'd be cosine over cosine, or 1 over cosine.
Which would be secant cosecant.
So you want that?
isn't funny anymore.
You want
What
that?
was it funny? I don't know.
Can we take the antiderivative of secant cosecant?
No.
No.
So then the problem is invalid and you stop there, right?
No.
Oh, Jim, you left us on the wrong road.
We go back to here. Okay? What's the relationship between tangent and secant squared? If we take the derivative of tangent and secant squared, so if you have both in the same integral, if you let u be tangent, then du is secant squared x dx, and
It's all there.
you can replace it.
Du be on top.
Du over u, 1 over u du, it all means the same thing. Yeah. So,
Wait, so can you explain how you get to like,
because secant squared dx, we can replace with du, and tangent of x becomes u. So, like Jimmy said, you may see this as du over u. Right, yes. But I like to write them separately. That way, that 1 over u can stick out and scream my antiderivative is.
ln of x,
ln of u.
ln of u. Thank you.
Okay. So our answer to the original problem is the natural log of tangent.
Oh, so it's always going to be the denominator.
So, could you have made secant squared your u then? Or would you always make the denominator?
Well, you might try and
Because the derivative
Ah.
seems squared.
you might try it out like, oh, what if I let u, because we don't have one rule for secant squared over tangent, right? So we tried to simplify it, that didn't work for us. Our only other option is, substitution. So what if I let u be secant squared x? Well, then du would be 2 secant to the first x times chain rule
Yeah,
secant x tangent x dx.
Yeah, I think I will.
And that's not helpful, is it?
You have to divide like.
So I'm glad you brought this up though, Aaron. There could be times where you try to do a u substitution, but when you take the du, that there's not that substitution to make. All right. And so then you will know, okay, I didn't pick the right u, or maybe this isn't a substitution problem to begin with. Okay. So sometimes you may have to test the waters, but when you take your du, you'll know if it's okay.
I have a question.
Yes.
I'm kind of curious. Basically, for the integral right there, what if it was integral 1 over u squared?
If it was 1 over u squared, then it would be a power rule.
Okay, so it's only applied, so it applies only if it's u to the negative first.
Yes.
Okay,
Any other power, we use the power rule.
okay,
Mhm.
that makes sense.
Yeah, and that's something that at the end of last semester we all felt really good about, and then we had winter break, and now we have to kind of re-remember those things. So. I want you to look at this one. I want you to think about it for a little bit. Not out loud. To yourself.
Isn't it just,
I want you to think to yourself, please. Now, within your pod, talk about any ideas that you may have.
I would just put it in.
Natural exception.
What did you say?
Natural exception.
Wait, one over the natural log is
one over the
Yeah.
I don't know, I'm just figuring it out.
the eighth and one?
It isn't.
Yeah.
Okay, so ideas. Separate it. So you want me to write 1 over x times 1 over the natural log of x? Okay, that might be easier for us to see what's happening here.
That's natural log, that's natural log x over natural log x, which is 1. That's what I said.
Okay, Jimmy is seeing a relationship, but he's not seeing the relationship. He's noticing.
elements times e is one over natural log x is correct, and then it's 0. Product rule.
Okay, so first of all, we can't take the integral of each of these separately and multiply them. That's not a thing. If they were added, yes, we could. Multiplied, not so much. Okay? However, is there a relationship between the natural log of x and 1 over x? There is. What is the relationship?
Derivative.
Okay, if we take the derivative of natural log, we know that we get 1 over x. How can we use that relationship to help us?
We'll make that u.
Okay, if you see that relationship, I know that this is the derivative of this. You might have a substitution in there. If u is the natural log of x, then du is 1 over x dx, which we have right here. And that's what Jimmy was seeing. He just got really excited and wanted everything to cancel out. Okay? But instead, what we have is the integral of 1 over u du. Right?
So we get 1 u.
So we get the natural log of the absolute value of u plus c, which is?
Natural log and natural log of
I told you it's natural section.
Cell-based.
I was right.
You were right, Bert.
I don't think in the real world we'll ever need to do that.
No, I said.
Okay, now, it is possible, but any job that you're going to go out and do you need to be critical thinkers? Yes, you need to be critical thinkers. This skill requires critical thinking. You have to see patterns. Okay?
That's why we're doing it. That's why we're doing it. Can't we just look at like patterns that we're working with?
I've asked the last
Patterns
one.
are my friend.
Yeah.
From 1 over u du, so it's the natural log. It's a natural log. How did you, I'm not really seeing that.
So do you see how I got from here to here?
Yeah, oh,
Okay. Well, u is the natural log of x, so I plugged it in.
Is that tangent of x, or is that
Tangent x dx.
Change it to sine and cosine.
Oh, that is an excellent idea. Because we don't have a rule for just the antiderivative of tangent, do we? No, but instead, I agree, we can change it to sine of x over cosine of x. And how is that helpful?
derivative of cosine is negative sine.
Okay. Okay, so we have two relationships. Derivative of sine is cosine, derivative of cosine is negative sine. Which one?
We want the sine, we want to use sine. U equals sine because then du would equal cosine. But we wouldn't have to deal, but we wouldn't have to deal with no negative.
If we chose this, we don't have cosine of x dx. We have 1 over cosine x dx, don't we? Okay? Now, you aren't the only one to think of that, Aaron. Okay?
No, Aaron was the only one.
No. So, but see, this is what I was talking about earlier. You may try to make u something and then get to your du and realize, darn it, that's not going to work. Okay? Good question, Karen.
So then,
Okay, this can't work because cosine x dx would require cosine to not be in the denominator. Okay? So instead we need to use u as cosine of x. Sorry. That way our du, even though it's negative, we have sine x times dx in our integral right here. And so we can make that du substitution. But what kind of du do we need to substitute?
Positive. We'll put negative.
negative du.
So when we take the antiderivative, we end up getting negative natural log of the absolute value of u plus c. And so then we can okay. I would like you to please take the antiderivative of cotangent. So please take the integral of cotangent dx. Cotangent of x dx. Yeah. It is only the first Friday of the semester. We have a lot more.
We're like 18 Mondays old.
Seniors should get out in February. You know?
There's
Like,
a reason that you guys get senioritis.
okay, but we're like going to college, it's like, we've already applied and gotten in, and now we like, what is this all matter, right?
You still have to be prepared for where you go this year.
Why?
You're not in school just to get into college.
No, it's just.
You're in school to prepare you and to learn, yes.
Yeah.
You need to finish this semester so that you're ready for next semester.
Yeah.
Yeah, why can't we just do it with that? Like, right after you drop out.
Sure, papers.
Believe me, we're gonna be ready to get rid of you after Easter.
Exactly, so let's just.
I'm just kidding.
Shut up.
Jimmy, what did you get for your answer?
The same thing, but you take out the negative and put in sign X.
You take out negative.
So we have to only have two things. Wait, who's
Zach and Josh are juniors.
Zach?
Zach, stop.
So that's cool.
Well, how are you gonna only have two
Okay,
people?
this is what Jimmy got. You agree?
Of course it's right.
Wait, is it gonna be like last year where they still have to do a whole other?
Well, they're probably going
got
to
it.
show.
Why are you looking at me, Natasha?
They're gonna do the target. I'm not even looking at it, nothing about you.
Dude, I still have that written.
Aaron,
Karaoke day after AP.
just pay attention to
I
you.
don't know, man.
Get off your phone.
Okay, we have a couple more examples.
Who are you texting?
Hang in there.
Oh.
Why?
God.
Do you really think I enjoy making you whine?
Yes. We're gonna be leaving this class in like 10 minutes, you know, we're already like.
Write it down. Unless you want to just think on this problem on your homework. Okay?
Oh, this is on our homework?
Does anybody notice?
Pathetic factors.
Oh,
That's
God.
it?
No.
Oh, no.
Yeah.
What's that? No,
The numerator is one on top is one larger than one.
Okay, so the numerator's bigger,
Oh, no.
not the denominator. So what kind of fraction are we dealing with? If the numerator's larger?
Oh, what's it called?
Um,
Like 11/5. What's that called?
Improper, very good, John.
There we go.
Okay,
I haven't heard that word.
improper fraction. What can we do with improper fraction?
take out numbers.
We haven't asked. Okay, there's too many people talking.
Can't we divide?
We can divide.
Oh,
No! I heard.
Wait, hey, just one question. That thing where you put like the 2 in the corner and then like right down.
Would you like to do that instead?
No! It's so much easier. So much
Stop arguing! Brady, on your piece of paper, you can do synthetic division.
That's the thing I don't really remember.
Okay, so here we go. X goes into 2x squared how many times? So then x minus 2 times 2x gives us 2x squared minus 4x. And what do we do with those?
Subtract it.
We subtract them. X goes into 11x how many times? And then x minus 2 times 11. And what do we do with those? So our remainder is, I'll let you try that again.
Zach, you should give
Okay. So instead, we have the integral of 2x plus 11 plus our remainder, 19 over x minus 2.
Oh my god.
That's a big number.
Wait,
Wait, so that's not, you can't do it. But that's not.
You can.
Wait, what?
Since we're adding, we can take the integral of each term. Okay? We have actually made this a very simple problem now. Because what is the antiderivative of 2x?
X squared.
plus, what is the antiderivative of 11? Plus, what's the antiderivative of that fraction?
Oh, now we have to do the
Substitution.
jump.
We don't have to do substitution.
Oh, it's just.
19 is our constant. We have 1 over x minus 2, so that's going to become
X minus 6 squared.
That's still
It
true.
wasn't fun at all. You said it would be fun.
She lied.
I'm not sure if I said the word
See, when
fun.
there's a constant up top, I don't see the ln, there's a constant.
Hey, you should take a step.
So you took the 19 and then do 1 over x minus 2.
Okay, so this right here we can rewrite as 19 times 1 over x minus 2.
Oh.
Does that help make the connection?
Then it's 1 over, okay.
Mhm. Uh-huh. We do take that course, it's called student teaching. Great design, isn't it?
Oh. You got roasted.
Didn't you say that we should take a class on like what to say when you ask questions? It's called student teaching.
Oh, you
You just gotta do it.
That was a degree.
Okay. One last problem. One last example.
There.
Woo!
We didn't even do the 7 slide,
Okay. So e to the x. What's the derivative of e to the x? What's the antiderivative of e to the x? Okay, good. You remember the simplest rule ever. So, what can we do here?
Make u e to the x plus 1.
Since e to the x plus 1 is inside of something squared, it's a great candidate for u substitution. And then when we take du, we get e to the x dx, which, look at that, ladies and gentlemen, we have that right there.
Never say that again.
Swag yellow.
Yeah, don't say that.
Okay, Emma, what is this antiderivative? 1/3 u cubed plus
That wasn't actually that way.
Said it all along.
Why couldn't we do that one earlier?
Yeah, that one looks spooky at first, but now it's just easier.
I'm so see. Probably don't.
We just gotta
Is it a problem that I saved the easiest for last?
Yes.
Normally that's stopped.
Can I do anything to make you happy?
Give us no hope. We can make the
Hey.
final.
Oh my gosh, the horn. Put every song in X,
We're
but
the
not
flames
the
on
one.
is that it?
Yeah, right.
Yeah, whatever percentage we got to 5 homes, that's it.
Oh my god. On easy or on
Yeah, I've heard.
What?